When we think about AI, we usually picture something that lives in the cloud, right? Something intangible. But what happens when you give that intelligence a body? A brand new analysis is arguing that this isn't just about making smarter robots. It's about a technology that could totally shift the geopolitical balance. So let's break down what embodied AI really is and why it's such a big deal.
And this really isn't science fiction anymore. A recent analysis starts with this very stark question. What actually happens when a machine, whether it's on the ground, in the air, or under the sea, can perceive its environment, understand what's going on, and then act completely on its own to finish a mission? Well, this is the new reality we're facing with embodied AI.
So what are we actually talking about here? It's called embodied intelligence. And the core idea is pretty simple, but powerful. It's the fusion of knowing and doing. It's about giving a physical robot the ability to see its environment, figure out what it's looking at, and then make its own decisions. We're talking way beyond just following a pre-programmed path.
All right, first up, let's dig into why this isn't just a simple upgrade. This is a fundamentally new kind of robot, and it has massive strategic implications.
The analysis we're looking at really zeroes in on China's push into AI, framing it as a core part of their national strategy.
And this strategy isn't just about building better robots. It's this whole multi-pronged approach. You've got military-civil fusion, which basically means a cool innovation in a factory today could become a military tool tomorrow. The endgame? Global tech dominance. And they plan to get there by building a massive data barrier. Think about it. So much real-world training data from all their industrial robots that competitors just can't possibly catch up.
So what does this actually look like on the ground? Let's explore the real nature of this threat and the specific new capabilities that pose some serious, tangible risks.
This slide really shows the incredible leap we're talking about. On one hand, you have a traditional robot. It needs a map, it follows rigid instructions, and it basically just sees shapes and geometry. But an embodied AI, it can walk into a completely unknown area and understand intent. It doesn't just see a truck. It understands that truck might be a threat, or a supply vehicle, or part of an enemy convoy. It's perceiving strategic meaning. That's a game changer.
The analysis even gives us a really concrete scenario. Picture this. A small robot gets sent into hostile territory, no map. It starts building its own 3D model of its surroundings, what they call a semantic map. It's like a video game map where every object is automatically labeled for it. Enemy patrol, good cover, potential threat. And based on that live map, it makes its own decisions to dodge patrols and then reports back not just what it saw, but what it understands about the enemy's setup.
And this is where it scales up, like dramatically. You integrate large language models, and suddenly a single human operator isn't micromanaging one robot at a time. Instead, they can just issue a complex command in plain English, something like, secure this area and keep an eye on all the roads. And an entire swarm of robots then coordinates itself to execute that mission. The loop from decision to action basically shrinks to zero.
And we're not just talking about robots on the ground. The analysis warns about a multi-domain swarm. Just imagine this: unmanned ground vehicles, aerial drones, and sea drones all sharing one brain, one single semantic map. A ground robot spots a hidden threat, and it instantly tells a drone flying overhead, which then relays that info to a vessel offshore. Our traditional defenses, which are usually designed to fight in one domain at a time, well, they're just not built for this.
Okay, so that sounds pretty scary. How do you even begin to fight back against something like that? Well, the analysis actually proposes several clever asymmetric countermoves specifically tailored for Taiwan.
This table lays out what they're calling a strategy of embodied countersystems. So to stop that autonomous infiltration, you'd use a mix of physical barriers and your own smart AI systems designed to hunt and capture them. But check out that second one. It's fascinating. To defeat an AI that understands a scene, you introduce semantic noise. This is like digital camouflage for an AI brain. You're feeding it false data to make it misinterpret what it's seeing. So instead of just jamming its signal, you're actually tricking the robot's mind. The report really pushes for Taiwan to build what it calls a locally unique defense. What does that mean? It means creating AI with social perception that can spot a disguised threat in the middle of civilian traffic. It means leveraging their world-class semiconductor industry to build specialized, hyper-precise robots that literally no one else can match. It's a whole strategy built on their unique industrial strengths, all backed up by secure talent and supply chains.
All right, let's zoom out for a second and look at the future impact of these, well, thinking machines.
And this, right here, is the core takeaway from the whole analysis. We are crossing a critical threshold. These advanced systems are no longer just tools that are executing human orders. They're actually becoming entities with the capacity to make their own limited tactical decisions right there on the battlefield.
This one quote from the source document just captures the paradigm shift perfectly. The freedom and power of physical action. That's both the goal and, honestly, the challenge of this entire new technological frontier.
So this all leaves us with a massive question, one that goes way beyond any single country or conflict. When a machine can start making its own tactical decisions, what does that really mean for human control? In war, and maybe even in peace, that's a question we all need to start asking.